Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about coordinate geometry of the circle. Now the question that I've chosen to go through here is 2017 Paper 2 Question 4 Part A. In this question we're given the coordinates A, B and C. We're told that these three coordinates are all points on a circle. Now if you know that these three coordinates are all points on a circle, immediately you should realize that every single circle can be written in the form of x squared plus y squared plus 2gx plus 2fy plus c equals 0. You can take that directly from your log tables. And in this equation you have three unknowns, g, f and c. So if you're able to find g, f and c, you can write the equation of any circle. If you've been given three pieces of information and you have three unknowns, you should realize that the easiest way to do this question is by simultaneous equation. So first of all, I subbed in the coordinate a. I know the coordinate a is the coordinate 0, 0. That means that when x is equal to 0, y is also equal to 0. So if I just sub it in, everything cancels out and you end up working out that c is equal to 0. The second thing I did was I subbed in the coordinate b, where when x is 6.5, y is equal to 0. So if I just sub that into the circle, notice now this time I'm subbing in 0 instead of c as well. That allows me to work out that 42.25 plus 13g is equal to 0. Which means I work this out and I end up with g is equal to minus 42.25 over 13, or minus 3.25. Now all I need to do is find f. And in order to find f, I'm now going to sub in the coordinates x is equal to 10 and y is equal to 7. So I'm going to start that again at the top. Now that we've worked out what g and c are equal to, the only thing we don't know is f. Okay, so now I'm going to use the fact that when the coordinate c tells us that when x is 10, y is equal to 7. So I can just sub in these four variables. I'm subbing into the equation from my log tables. I know that c is equal to 0, g is equal to minus 3.25, x is equal to 10, and y is equal to 7. All I did here was I subbed that in, and I worked my way through the question, and I end up with f is equal to minus 6. Once now I know c, g, and f, I can find the equation of the circle. So now I sub back into the formula in my log tables. Instead of g, I put in minus 3.25. Instead of f, a minus 6. Instead of c, a 0. So my final answer is in the box here. The final part of this question asks me to find the angle BCA. Now you'll notice that I've plotted my coordinates roughly. Imagine if that was my x-axis, if that's my y-axis and that's my x-axis, my coordinates would roughly be there: 0, 0, 6.50 and 10, 7. So roughly ABC, that's the triangle I'm dealing with. There's a number of ways of doing this. Obviously this is a non-right angle triangle, so what you could do is you could use the cosine rule. You could work out the distance AC, the distance BC and the distance AB, and then use the cosine rule to find this angle. However, probably a more straightforward way of doing it is by using the formula to get the angle between two lines. In order to use the formula to get the angle between two lines, you need to know the slope of each line. So the first thing I've done here is I found the slope of AC. If I'm getting the slope of AC, I'm going to use the formula y2 minus y1 over x2 minus x1. And if I sub into that using the coordinates A and the coordinates C, I end up with 7 over 10. If I do the same thing to get the slope of BC, this time my x1 is 6.5, my y1 is 0, my x2 is 10, my y2 is 7. If I just sub into that, I work out that the slope of that line is 2. So now I know that the slope of the line AC is 7 over 10. The slope of the line BC is equal to 2. If I know the slope of that line and I know the slope of that line, I can use this formula to find the angle between the two lines. Now that I've worked out the slope of AC and the slope of BC, it's relatively straightforward to get the angle between the two lines. If I sub into the formula, tan theta is equal to plus or minus m1 minus m2 over 1 plus m1 times m2. I know that one of my slopes is 7 over 10 and the other one is 2. So all I've done here is I've subbed in 7 over 10 and I've subbed in 2. And when you work it out, you get tan theta is equal to plus or minus 13 over 24. Now you have to recognize that when you have two lines, they make two different angles with each other. If you imagine if I extended these two lines on, that's the line AC, that's the line BC. Obviously one of the angles that these two lines make with each other is an obtuse angle. However, I'm clearly concerned with the acute angle. I'm concerned with this angle here. Based on our diagram, we can tell that our angle is clearly between 0 and 90 degrees. If our angle is between 0 and 90 degrees, that means it's in the first quadrant. So, and in the first quadrant, sine, cos, and tan are all positive. So I know for a fact that when I get to this line, I want the tan of my angle to be positive, because it's clearly an acute angle. So I can just ignore the signs there and just take this as tan theta equals 13 over 24. To get theta, I just get tan inverse of 13 over 24, and to 2 decimal places, it works out as 28.44 degrees. Okay, so I hope that video makes sense. If there's anything there you're struggling with, then just let me know in class or send me an email and I'll try and clarify it for you.